Our last section we're going to cover this semester is solving trig equations. And we've done a little bit of this before. This is getting a little more complicated. Remember when solving a trig equation, when we did these before, we always tried to make it work things down to one of two forms. Trig function equals trig function, or trig function equals a number. So that's sort of the goal here. I mean, they're starting out a little more complicated than we did before. But that's the first goal. Get trig function equals trig function, or trig function equals a number. Now remember, when we did trig function equals trig function, they either turned out to be the same trig function, you know, sine of something was sine of something else, and then we assumed the two angles were the same, or they were co-functions. Sine of something is cosine of something, for example, or tan is cotan or secant is cosecant, and then we assumed the angles were complements of one another. So those are the only two types we've done. But we may have to use that here, but most of these are coming down to trig function equals a number. So our first example says, solve the equation sine x plus 2 equals 3 over the interval 0 to 2 pi. So the angle, x is an angle here because you're taking sine of it. The angle, they only want answers from 0 to 2 pi. There's an infinite number of solutions to this, but they only want answers from 0 to 2 pi. One revolution. Right? Now, this plus 2 is not part of the angle, right? Order of operations is take sine of x, then add 2. So the x is not part of the angle. Even if you didn't have a clue where to begin or where we were going, what does your instinct tell you to do with this equation, right? Get the trig function by itself. Subtract 2 from both sides. You get sine of x is 1. Right? Notice its trig function equals a number. That's another clue to go ahead and subtract 2 from both sides. So you have trig function equals a number. Okay? Well, we're trying to find values of x, angles whose sine is 1 from 0 to 2 pi. Let's draw a picture. We're only going one revolution, right? So the first thing you ask yourself before drawing the picture is, in which quadrant could x be? Well, in the first quadrant, sine of an angle is positive. So there is an answer in the first quadrant. Now, where else is sine positive? Sine is also positive in the second quadrant, right? Right? Opposite over hypotenuse, opposite over hypotenuse, y over r. Right? So there's going to be two answers here. Now, you may ask yourself, well, wait a minute, why didn't I just stick to the first quadrant? In the last section, I said sine was positive, I'm only in the first quadrant. Notice I didn't write x equals sine inverse of 1. Right? Sine inverse of a number is an angle, and the angle would be in the first quadrant only. Right? We're not writing these with sine inverse, okay? So it doesn't say only find the answers in the first quadrant, right? So be careful about confusing this with what we did in the last section. Certainly, sine inverse of 1 is a solution. It's this one. But there's another one here to find. Okay? Now, again, I'll do what I always do. Right? Now, if I think of that as over 1, right? Sine 1. That's opposite over hypotenuse, and then you realize, oops, I have the leg and the hypotenuse the same size. That can't happen. So my picture here doesn't make any sense. Okay? So what does that mean? So what do I do? The triangle picture didn't make any sense, so what is it? It's a quadrantal. So my answers are really quadrantals. So it's either going to be here, or here, or here. That's the point 1, 0, that's 0, 1, that's minus 1, 0. Okay, so again, I wasn't even looking ahead. I just drew triangle pictures because that's what I usually start with. I realized it was a problem. Fine, now I'm trying quadrantals. Now, when you pick the points on the unit circle, sine is 1. Which number is sine? Right? Sine is the second number, right? So I thought there was going to be two solutions with my two triangle pictures, but there's really only one. The only solution is that. And what's x? That's pi over 2. Right? So I always try to draw triangle pictures. It didn't make sense. That's a dead giveaway. Oops, let me do the quadrantals. And there's only one answer here, because sine here is 0 and sine here is 0. Okay, so there's only one solution from 0 to 2 pi. So that's our first example. Okay, now before we do the second example, let me remind you of something. For example, this isn't part of the notes, but suppose I had the equation x squared equals x, and I said solve for x. So it doesn't have anything to do with trig. What some students want to do is they'll say, whoa, there's an x on both sides, let's divide both sides by x. X squared over x is x over x is 1. And they'll say, okay, there's your solution. Now let me look, now 1 is a solution to the original equation, right? 1 squared is 1. But there's another solution. X equals 0 is also a solution. 0 squared is 0. But notice, when you divide both sides by x, you lost that solution. Okay? So whenever you have an equation with variables on both sides, if you divide both sides by the variable and they cancel on both sides, that's dangerous. You have to be careful because you may lose the solution. How do you solve this problem? Well, it's a quadratic equation. You've got x squared. You put everything on one side, right? Subtract x from both sides, set equal to 0. What do you do now? You factor. And the first step in factoring is always pull out greatest common factor, which here is x. That's x squared, that's minus x. Something times something is 0, so either x is 0 or x minus 1 is 0, right? If something times something is 0, one of the factors is 0, so either x is 0 or x is 1. And there's your two solutions, okay? So that's how you solve something like that. If you divide both sides by a variable and it only cancels out on one side, that's fine. You're not going to lose solutions. If it cancels on both sides, you may lose some solutions. And I bring that up because the next example says solve tan cubed x equals tan x. So if you divide both sides by tan x, notice it'll cancel on both sides, you may lose some solutions. Actually, in this problem, I don't think you do, I say. But let's be careful and not cancel, okay? So you don't want to cancel on both sides. I say you don't. Maybe I'm not remembering correctly. So let me write down the equation we're trying to solve. Again, they only want the answers from 0 to 2 pi. The angle is 0 to 2 pi 1 revolution in radians. If it didn't specify, I guess you could give your answer in degrees or radians, whichever. Okay, so I'm not going to divide both sides by tangent because I may lose some solutions because it cancels on both sides. So what do? Put everything on one side, subtract tangent from both sides. And notice I have an expression set equal to 0. So what do? Well, it shouldn't surprise you. I'm going to do what I did before. Let's try to factor. First step in factoring is pull out the greatest common factor, which is tan x. So if I factor out of tan x, I get tan squared x minus 1. Right? Always check your factoring by remultiplying. Tangent times tangent squared is tangent cubed. Tan x times negative 1 minus tan. We would have lost solutions if I had divided by tangent. So notice I have something times something is 0. So let me write it up here. So either, either tan x is 0, that's equal to 0, or tan squared x minus 1 is 0. That's what that gives us. So either that factor is equal to 0 or that factor is equal to 0. Okay. So let's keep going. I have trig function equals a number, so I'll come back to that one. We need to keep going here. So tan squared x, if I add 1 to both sides, I get tan squared x is 1, add 1 to both sides. And then you take the square root. When you introduce a square root, you have to take the plus or the minus. So this says tan x is plus or minus the square root of 1, which is plus or minus 1. When you introduce an even, if this had been tan to the fourth is 1, I would have tan as plus or minus the fourth root of 1. When you introduce an even root, second root, fourth root, sixth root, you have to put plus or minus. So there's really three things I'm solving here. Tan is 0, tan is 1, or tan is minus 1. Okay, so I'm going to, tan is plus or minus 1. Let me make some room here. Yep. So I'm going to do tan x is 1, or tan x is minus 1. Okay, so I have three things to do. Trig function equals a number, trig function equals a number, trig function equals a number. Right, so if I had divided both sides by tan x, I would have lost the solutions from here. Okay, well let's just do one at a time. Tan x equals 0. I know these are quadrantals because you can't draw a triangle picture with a side of 0. So I know I have a quadrantal here. I'm going from 0 to 2 pi. I'll just go all the way around. So that's the point 1, 0, 0, 1, minus 1, 0, 0, minus 1. Remember the first number is cosine, the second number is sine when you use the unit circle. Now, how do you get tangent out of that? Remember, tangent of x is sine x over cosine x. So where am I going to get a sine over cosine equals 0? Or you can say tangent is a y over x if you want to think of it that way. So where are you going to get tangent is 0? Here and here, right? Sine over cosine, sine over cosine. So the two answers here, right here is 0 radians. Again, they asked for the answer in radians. And here is pi radians. Now, you get another answer, if you go all the way around, you get another answer at 2 pi, but remember, parentheses means don't include. So if that had been a bracket, we would have had 0, pi, and 2 pi, right, if that had been a bracket. Okay, so we have two solutions right now. Okay, now what about tan x equals 1? Well, where's tangent positive? Tangent is positive in the first quadrant and the third quadrant. And then think of that as over 1, so tangent is opposite over adjacent, opposite over adjacent. Notice in the third quadrant, both of those values are negative. X and Y are both negative 1. I don't really need the other side, but you know these are your special triangles. 1, 1, square root of 2, square root of 2, no problem. Now, what's the reference angle for both of these in radians? Well, it's your 45, 45, 90 triangle, so the reference angle is pi over 4. Pi over 4. Now, what are the actual answers? Those are the reference angles. Well, in standard position, from here to here is pi over 4. Easy. Now, how far is it from standard position here to here? What angle is that? It's pi, right, halfway around pi, plus pi over 4. So it's 1 pi and a fourth pi, which is 1 and a fourth pi, or 5 pi over 4. Right, so I just did pi plus pi over 4. Get your common denominator. Right, pi plus pi over 4. Now for the last piece, well, we just said tangent is positive in these two quadrants, so tangent is negative in the other two, in the second and the fourth. Again, think of that as being over 1. Tan is opposite over adjacent, opposite over adjacent. Notice in the fourth quadrant, y is negative, and in the second quadrant, x is negative. Again, the hypotenuse is square root of 2. It's, again, your 45, 45, 90. The reference angle is pi over 4 for the reference angle. So all we have left to do is figure out those values. Well, how far is it from here to here? Well, I would say pi minus pi over 4, right? Halfway around is pi, back up pi over 4. So 1 pi minus a fourth pi is 3/4 pi, 3 pi over 4. To make this easier on ourselves, couldn't I just say this angle is minus pi over 4? Right? Minus pi over 4 is this triangle picture. Minus pi over 4. Minus pi over 4 is the solution to this equation. However, they don't want that answer, right? 0 to 2 pi. So minus pi over 4 is the solution, but they don't want that. You have to go all the way around that way in the positive direction. So how far is that? All the way around is 2 pi, and then back up pi over 4, which is 7 pi over 4. Again, I did 2 pi minus pi over 4, right? All the way around is 2 pi, back up pi over 4, that's 7 pi over 4. So notice, wow, to this equation we had 6 different solutions, and that's just in the first revolution. Every revolution you go, you're going to have another 6. So there's a lot of solutions to this trig thing. So that's a long one. Okay. But notice, once you get down to trig function equals a number, trig function is number, trig function, it's drawing the pictures that we've been doing all semester. So the new thing is just getting down to trig function equals a number. That's the only new thing. So I know that some of these problems are long, but if you break up into pieces, first get to trig function equals a number, then draw your triangle pictures, or your quadrangles. The next one says solve the following: cosine squared x plus 2 cosine x plus 1 is 0. And we're going again from 0 to 2 pi. Just one revolution in radians. Okay. Well, what does this problem look like? If cosine x were like, w, what would this equation look like? It'd be w squared plus 2w plus 1 is 0, wouldn't it? If I replace cosine x with w, that's what it would look like. This is a quadratic equation. What methods do you have for solving quadratic equations? You can either factor, use quadratic formula, or completing the square. Again, if you're going to complete the square, you might as well use quadratic formula, right? So this is called a quadratic equation in cosine x. So if you think of cosine x as another letter, it's a quadratic with cosine x replaced. So I'm just going to, some people like to do a change of variable like I just did, but I'm just going to go ahead and factor. Right? It's 3 terms, so I'm going to try my double business. Right? First term times first term has to be cosine squared x, so it makes sense to try cosine x and cosine x. Cosine x times cosine x is cosine squared. And what times what is 1? Well, 1 times 1. And since the coefficient of the middle term is plus, I'm going to try plus and plus. Now, be careful. Just because I put the things that need to work doesn't mean that they actually work. You have to check that. Always check your factoring by multiplying. Cosine x times cosine x is cosine squared x. 1 cosine plus 1 cosine is 2 cosine x. 1 times 1 is 1. I can't tell you how many times I've had students do this sort of thing, and the thing that messes up is the constant. Because the first is the hard part. And they say, oh, that works, so I'm good. But check your constant. Plus 1 times plus 1 is plus 1. Okay, so now I have something times something is 0. So either cosine x plus 1 is 0, or cosine x plus 1 is 0. It's the same thing, so I don't need to do it twice. So cosine x plus 1 is 0. Well, if I solve for the trig function, I get cosine x is negative 1. And I worked it down, the trig function equals a number. This is the new stuff. And it's really not that new, because you learned how to factor a long time ago. You just didn't have the cosines in. Okay, so I have trig function equals a number. Well, if you try to draw the triangle picture, I just did this on a couple problems ago, right? You're going to have cosine, remember, is x over r. You're going to have x and r being the same length, which doesn't make any sense. So it's not a triangle picture, it's a quadrangle. Okay? So I'll go back to my usual. Right? I know the answer is a quadrangle. We're going all the way around. Again, I should just leave this picture up here. I keep using it. Now, where's cosine equal to negative 1? Remember, on the unit circle, cosine is the first number. So those are no good, right? That's sine, not cosine. It's there. So it's from here to here, and what's that angle? Okay. Okay. So let's do another variation. Now they're changing the instructions on this one. It says we're looking at sine squared x minus sine x is 0. And it says in radians, but notice it says find all solutions. It didn't say from 0 to 2 pi. So that's the new variation, but it's one little extra step, so it's not that hard. Okay? So to find all solutions, let's just find all the solutions from 0 to 2 pi first. Let's just start there. Okay, so I'm going to find all the solutions from 0 to 2 pi. Well, I already have this expression set equal to 0. What do you think we ought to do? Well, both terms have a sine x. Let's pull out the greatest common factor. Sine x, that's sine x minus 1 is 0. Sine times sine is sine squared. Sine times negative 1 is negative sine x. So I factored correctly. So I have something times something is 0. So either sine x is 0 or sine x minus 1 is 0. Either that factor is 0 or that factor is 0. This means sine x is 0. And again, sine is 0, you know it's a quadrangle. Sine is 1, if you think of that as 1 over 1, it can't be a triangle picture because then the opposite, the hypotenuse, would have the same length. So both of these are quadrantals. Maybe I should just draw it over here and leave it. Okay, I'll just leave it. Okay, now where's sine equal to 0? Again, I'm just doing in the first revolution. So where's sine equal? Sine's the second number. So right there, so x is 0, radians. And sine is also 0 here, which from there to there is x is pi. I'm writing them on two separate lines on purpose. And again, I'm not going to do 2 pi. 2 pi is also an answer, but I did the 0. They're coterminal, so I didn't bother. Now where's sine equal to 1? Sine's the second number. The only second number that's 1 is up there. And notice that's pi over 2. And here to here is pi. Okay, so we have 3 solutions in the first revolution. Again, 0 and 2 pi are coterminal, so I just put the 0. I didn't count the 2 pi. Now, so those are so if this had said find all solutions from 0 to 2 pi, that would be my answer. Okay, so we're good. All right, but the question said find all solutions. Well, I just alluded to this. Isn't 2 pi a solution? If you go all the way around, right, sine is 0. Or if I went around again, 4 pi, that would be a solution. Or 6 pi or 8 pi. Or negative 2 pi, right? I'd be here. Right? So since I found 0 as a solution, I know that any angle coterminal with that, any angle that stops here is going to have a sine of 0. So any angle coterminal with that is going to also be a solution. But we did this early on in the semester. Once you have an angle, how do you find angles coterminal to it? At the time we were doing degrees, it was add or subtract 360 degrees from it. Add a 360, add a 360, add a 360, or subtract. Right? But now we're doing radians, so what would that be? I'm at 0. How do you get a coterminal? Add 2 pi or subtract 2 pi. Okay? So how do you write that to indicate all of them? Because I just don't remember when we did this before, the instructions said find 3 angles that are coterminal. We actually need all of them here, not 2 or 3. Here's how you do it. Put plus 2 pi in. So I'm going to add where n is any integer. Remember the integers are 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, dot, dot, dot. Okay? Notice if n is 0, I'm at 0. If n is 1, I'm at 2 pi. Right? Once around. If n is 2, that's 4 pi. Twice around. So the n is how many times around you're going. If n is negative 1, you're going that way. And you still stop there. And basically it's the same argument for the other, right? If you're at pi, how do you get another solution? Go around again. So plus 2 pi n, plus 2 pi n. Now I also said subtract. I don't put a plus here, but n can be a negative number, right? Integers can be negative, so you actually would be subtracting 2. So that's all the solutions in the world to this. So for anyone that says find all solutions, just find all the solutions in the first revolution, and then you put your plus 2 pi n. Okay, where n is any integer. 0, 1, 2, 3, 4, 5, dot, 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 minus 1, minus 2, minus 3, dot, dot, dot. Now, I'm going to caution you, I'm perfectly happy with this answer, but I want you to notice that in the back of the book, look at, like these two answers right here, notice 0 and pi radians form a straight line. So you can actually combine these two solutions into one. Because think about what this is saying. You're at 0, go around 2 pi, go around 2 pi, go around 2 pi. Here you're at pi, you're here, go around 2 pi, go around 2 pi, go around 2 pi. Which is perfectly fine. That gets you all the answers here and all the answers here. But couldn't you also do this? Combine those two. 0 is a solution, so is pi. What if I just went halfway? Add pi to that, you get a solution. Add pi to that, you get a solution. Add pi to that, you get a solution. So because the two solutions, 0 and pi, make a straight line, instead of going all the way around to get all those, and start here, go all the way around to get those, you can do them together. Start with one of them, go halfway, get another, go halfway, get another, go halfway, get another. So in the back of the book, instead of, they may do this, instead of writing those separately, they may combine them. So these two together, you could say x is 0 plus pi n. Notice it's not 2 pi, it's pi. So they're saying start at 0, add a pi to it, you're here. Add a pi, you're back here. Add a pi, you're here. So that's the dead giveaway they've done this. So if you ever do a problem and do this, and look in the back of the book and you're missing one, double check and make sure if it says pi and not 2 pi, they're combining two of them together. I'm perfectly happy doing it this way, but I want you to be aware if it's an odd problem, you look in the back and it doesn't match your answer, this is what they've probably done. Now this one you can't do it, you can't do that with, because there's pi over 2 was an answer, but not 3 pi over 2. So you can't do it with those two, with this one, because there's not a match over there. Just be aware. Okay? We keep doing everything in radians. What if this problem had said, find all solutions in degrees? So what would the answers look like here? This one would be 0 degrees plus what? It's not 2 pi anymore, it would be 360 degrees in. This would be 180 degrees plus 360 degrees in. This one would be 90 degrees plus 360 degrees in. Okay, so the pi over 2 is 90 degrees, but 2 pi would change to 360. What would the combined answer look like? That'd be 0 degrees plus 180 degrees in. So I just want you to be aware of how would you do this in degrees. That's what you would do. Okay, let's do the last problem here. Last example. Again, it's another, it says find, but they did just give you an interval again. It doesn't say find all of them, but I hope you realize finding all of them is just one extra step. Put the plus 2 pi in and the plus 360 degrees in. It says cosine squared theta is sine squared theta plus 1 over the interval. Here's one in degrees, 0 to 360 degrees. So they want the answers in degrees. Now here, you might be fine, let's just do what we did on the previous problems. Put everything on one side, set equal to 0. Well, if we did that, that's fine, but what's the problem? All the ones we did before, the greatest common factor was something besides 1. And one only had a sine and one only had a cosine x. That's not going to help you here, right? We have two different trig functions, okay? So what I'm saying is that if I move everything to the left, this is what you're going to get. And the greatest common factor is 1. That doesn't help you. You can't factor this. Okay? So what you can do though, if we had the same trig function, then we could maybe factor. Okay? One we did a couple times ago had a cosine squared and a cosine and a constant, right? So one was a cosine squared, one was a cosine, but we were still able to do the problem. We have a cosine and a sine. Well, we know how to convert a sine squared to a cosine squared or a cosine squared to a sine squared. Remember, we have the Pythagorean identity. Sine squared theta plus cosine squared theta is 1. Which one do I want to change? It doesn't matter. I'll solve for sine squared. So sine squared theta, right, if I subtract cosine squared from both sides, that's 1 minus cosine squared theta. We've done this before. Right? So I wrote down the Pythagorean identity that I know, and I solve for sine squared. Subtract cosine squared from both sides. So now I can replace that sine squared with 1 minus cosine squared. So let me do that. Cosine squared theta, that's this one, is 1 minus cosine squared theta plus 1. So that's my replacement. So I left that alone, I replaced sine squared with something it's equal to. Okay, so what do I have? I have cosine squared theta is 2 minus cosine squared theta. 1 plus 1, that's all I do. Okay, let me add cosine squared to both sides. If I add cosine squared to both sides, I get 2 cosine squared theta is 2. I just added cosine squared to both sides. And I'm getting rid of that. Divide both sides by 2. Cosine squared theta is 1. Divide both sides by 2. And I just want trig function cosine squared. I'm taking a square root of both sides. It's an even root. So I have to do plus 1 minus 1. Right? When you introduce a square root, you have to take the plus and minus. So notice I'm down to 2 things. So cosine theta is 1 or cosine theta is minus 1. So the new thing here is realizing you need to use an identity, a Pythagorean identity, to change one of these to the other. And notice once I did that, right, you get down to trig function equals 2 numbers. And again, I erased it. We're back to the quadrantals, right? If I put this over 1 or that one over 1, the adjacent side of the hypotenuse would have the same length, which can't happen. So it's quadrantal again. Goodness gracious. Right, so where is, now again, we don't have to do the plus 360 in here because they just said find all the solutions in the first revolution. Where's cosine equal to 1? Remember, cosine's the first number in the ordered pair. So there's 0. And we're in degrees here. 0 degrees, cosine's 1. But that's the only place cosine's 1. Now where is cosine equal to -1? The first number is -1 here, which is 180 degrees. And those are your 2 solutions. If this had said find all solutions, what would you do? Plus 360 degrees in, plus 360 degrees in. Or, because they're opposite, 0 and 180 are opposite, you could have combined them together and said theta is 0 degrees plus 180 degrees in, if you wanted to. But they didn't do that. It was just find all the solutions in one revolution, and there we go. So that's the last example in this section.